here now, we can now correlate what we've got here with that diagram on the board. Here we have copper top, copper bottom. So that's our top and bottom of the board, the conductive parts. We have a board outline, and that's where they will cut the board. Yeah? So if I draw a board outline with a circle on it, when I send it off and get it back, I will have a PCB which is a circle shape. Yeah? So your board outline dictates how your board is physically going to be cut.
And that's how they do Christmas trees and things you've seen in those hobby kits, haven't you? Yeah.
Silk screen top and silk screen bottom on our PCB. That is this bit which is printed on the top and the bottom, the black. Yeah. So if something's placed on the silk screen, then it will come out as text.
The writing. Okay. It's just sprayed on there in paint. That's all. Why would you want to do that? Well, because it's probably not going to be you that assembles it, because you're far too skilled to do things like that. You would get one of the technicians to do that, and they'd need to know what R1 was, so you've got to tell them where R1 goes. You see what I mean?
And then we have our solder mask top and solder mask bottom, and that's the solder resist. On our board, it's the whites on the top and the bottom. And you can control, if you need to, you can control whether you want solder to flow between pads and whether you want solder to resist the flow between the pads. But we don't need to look at that in much detail at the moment, so they're not selected, they're not turned on. And there's also another few things, the paste mask, the glue mask, but that's all down to how stencil machines prepare the board for when it goes in for pick and place. So at the moment we're going to concentrate on copper top, copper bottom, the board outline, and the silk screen top and silk screen bottom. So it has put all of these components on the board for me. And I can select each one of these components. Yeah? It doesn't know where I want them to go, it doesn't understand the thing I'm trying to make.
Just let me give a bit of clarity on that, Mike. So what you've got there is you've got the footprints that you selected before, but they're logically wired up, because we know from the circuit diagram. So they're wired with what's called a rat's nest there. So in other words, all the wires all crossed over and tangled up and everything. But that's the interconnections. And the machine is going to use those interconnections to tell the, to make the PCB and make the correct connections and route it so that they don't cross over each other.
So the board doesn't know what I'm trying to make. It doesn't know that I'm going to want a variable resistor on the edge of a board. It doesn't know where I want my connection for my power to be input. I need to actually place these components down. So to do that, I can drag them around. When I drag them around, I click on it once, and then click and hold. I can drag it. You can see that rat's nest is moving with me, because it's showing you, who's going to route the board with physical copper, where those connections need to be made. So in this case here, I'm going to just start nice and easy. I'm going to drop my IC right in the middle of the board. Now, here I have, if we zoom in, we have R4. That's my potentiometer. That's my variable resistor. So I'm going to want to put that on the edge of the board. So the first thing I'm going to do is I'm going to change its orientation, and I'm going to flip it around, and I'm going to stick it up here near the edge of the board, so that I know that when I'm soldered in there, my knob's going to be sticking out the board, not into the board. Yeah? So some basic orientation there is needed. And then if we zoom in, you can zoom in with the scroll of your mouse. Here's my surface mount potentiometer. Notice that I can actually select a pad. If I do that, I'll be trying to move the pad and it can't do that. I need to select a component by not clicking on a pad. And then I get my yellow box around it. Now I can move it. Yeah? So I can see here that this is looking to have a connection over here. So it's kind of pointless for me to put this component this side when I can put it this side and probably connect one of those wires much easier. Yeah? Otherwise, if I drop it here, I'm going to have to get a piece of copper from this point over the other side of that chip. And it's probably, just by looking at that rat's nest, I can see, yeah, that's probably going to look better over there. Yeah? So that's what I'm going to do. And now I'm going to go ahead and move the rest. Now this surface mount one, I might need to zoom in on that to select it.
It's just the roller ball doing that.
Just the roller ball, and then if I press and hold the roller ball, I can pan around. Okay, this one, looking at the rat's nest again, looks like it would be quite happily placed over here somewhere. Now, you can see I'm going to have a little bit of a bomb here. From when I look at my rat's nest, I can see that this connection wants to go here. That's great. This connection wants to go here. That's also great. And this connection wants to go up to my other pot. But this connection wants to run right through it. So that's something I'm going to have to keep in mind. You know, I'm going to have to make that connection. I'll show you how to do that in a minute. And I can also see here that these connections are going the other side of each other. So what would actually be better is if I change that, if I move this so it was, let's turn it 2 more times. Yeah? Now it's looking a little bit more like it can flow. This is why placement's actually quite important. Spend a little bit of time just understanding where your things are going to be placed. So again, we're going to look at this.
It's just like a knotted ball of string. You're looking in your initial design to try and unknot things and make them as neat as you possibly can. You won't get it perfect. And if you design a single-sided board, you won't even be able to route it properly under those conditions. But you can get around it because you've got jumpers and other things. But on 2-sided boards, you almost universally find a solution, which you'll find out in a minute.
Okay, so I've gone ahead and I've routed a few of these components. This I know is my output connector, so I'm going to want this on the end of my board here somewhere. And this one is my input connector here, so I've got an input here and an output there, volume control up here, and a little pot there. And now I can move my test point that we put down. Sometimes if you can't select it, you can just drag a box around it and select it. And my test point is going to go over here somewhere. Just stick it there nicely. Yeah. Okay, so now I have a basic positioning. Now look, this is actually turned around. Now I've positioned the other component. It actually, I think this is going to be better if we rotated it back. Now I've got much easier to flow it. Yeah? So now I've got everything placed, I need to actually connect it up. You can see that these pads here are green. What that actually means is that's the layer, the colour of the layer that they're going to be soldered on. And in this case, it's the top layer because that's also green. These through holes, they can be soldered both sides, so they're shown in blue. Because there'll be a hole drilled through the board and it can be soldered both sides. So it doesn't really matter, but it does matter for these. So if I want to make a connection now between this surface mount resistor pad here and this surface mount, because you can see my rat's nest is connecting them together. I want to draw a track. So how do we draw a track? We've got lines up here. If I make sure that I'm on my top layer, by double clicking this, yeah, so I'm actually working on the top layer, yeah, I then press my line button here, and you see how it snaps that crosshair into that green pad. So I'm going to start drawing my line there, and I'm going to finish it here. If I want to make another angle in there, because it's not good to have right angles. Electrons fall off the end. It's much better to have 45-degree angles or angles of some kind. So what I'll do is I'll move this over to where my crosshair is going through that pad, and I'll click again, and then I drag it up, I click again, and then once I'm that, I right click, and I click cancel. Now I have laid a piece of copper that connects this surface pad to this surface pad.
And what Mike's using here is what's called manual routing. So you can see the interconnections. There is a way you can do it automatically, but you don't have so much control over the shape of the track. So actually for something which, yeah, I mean, making PCBs is kind of an art form, you may be better off manually routing than automatically routing, but we'll show you how to do that as well.
Some would argue that you're always better off. I would never use an auto router, but we have to do it manually first to understand one thing. To use the auto router uses rules. And what we can't have is we can't have wires and connections that are so thin it's impossible to etch. So we actually need to make the width of our connection quite important. And let's just have a look at that. if I cancel this now and I move on, if I click on one of these wires here, let's double click it. Can I double click that? I think we can. Right. This is currently in mil, which is thou.
That's thousandths of an inch, which you may not be familiar with. But multi-skins are in America, so they still work in thousandths of an inch.
Okay, so this is using the net settings as my width. Okay, so we change that to millimeters, we might be able to see. So what this means is down here we have all of our nets. Drag that up. Okay, these are our nets. A net is a connection between two points. Yeah, and what it's saying here is a trace width, a minimum width, a maximum width. Okay, and this currently is in thou. I'm pretty sure it's going to tell me in thou. So this is saying that this particular wire here that I've just laid is 10 thou. Yeah? If I was to change that to say 25 thou, okay, you see how it's made that copper much fatter. If you want a standard PCB, the smallest you want to go down to is about 6 thou, and that is tiny. If you go less than 6 thou, your manufacturing costs are going to start increasing. If you go to 1 thou, you have no chance.
You've got no chance, and you're also going to find, and we found this last year, that we will have people with 0.5 millimetre wide tracks and so on. In principle you can do it, but as soon as you go into the soldering room and you start putting heat on it and you start putting your components on there and a bit of load, you'll find your track comes away from the board. So there you are, probably a week away from getting that board back again because you've got to send off for another one and so on. So as a rough rule of thumb, make that track as fat as you possibly can.
Yeah.
That's the rule of thumb, but not so fat it runs over the one next door.
No, and it's also, if it's too small, your manufacturing might have problems because etching isn't a perfect line. And so if it's really tiny, you might have an etching error where the track's broken before you've even built your PCB.
And also the size of the pad that goes on there, you can imagine a situation where for through-hole technology, the hole that they drill may actually be bigger than the pad you're trying to solder to, which is clearly a nonsense as well. Okay, there's one other thing that's worth noting. So trace width, very important. And